Hello everyone! We are Team Spatial Innovation, form the Deshang University. Today we want to introduce our project titled Landslide Assessment Using Spatial Intelligence. Cameroon's Western Highlands face a persistent challenge with landslides. Tragedies like the 2017 Fondonera Fosong Wencheng disaster and the 2019 Bafoussam Fokoué event have resulted in loss of life and extensive damage. Our approach brings together GIS, remote sensing, and the AHP-Saaty decision model to create dynamic susceptibility maps and real-time alerts for affected communities. The problem is urgent. In the Deshang Sancho escarpment, instability remains a threat, putting local populations at risk. By leveraging satellite data and spatial intelligence, my goal is to identify susceptibility zones to power early warning systems and inform safer urban planning. When you look at the Mifi area, you see a history marked by landslides, each event a reminder of the cost of inaction. Here's how it works. First, I defined the study area in Mifi. I extracted detailed slope and aspect information from digital elevation models. Next, I calculated the topographic wetness index, essential for understanding moisture-driven slope failures. For land cover, I used random forest classification with Sentinel-2 imagery. Then, I applied the Saaty AHP for multi-criteria weighting, ensuring each factor's influence was properly balanced. With all this, I computed the final susceptibility map. The system automatically calculates areas and generates alerts for high-risk zones. All results are exported as GeoTIFF and SHP files for seamless integration into existing systems. I built an interactive Google Earth Engine app, so users can visualize layers in real time, compute areas instantly, and export outputs with a click. The interface is designed for both technical pros and decision makers, making the insights actionable, not just academic. The results are robust. I mapped slope, aspect, TWI, and land cover classes across the region. The Saaty matrix achieved a consistency ratio of 0.06, ensuring reliable multi-criteria analysis. The susceptibility map highlights very low to high-risk zones, and the alert system pinpoints where intervention is needed most. This tool is now ready for authorities to use in urban planning, disaster risk reduction, and public outreach. Looking ahead, my solution is scalable and adaptable. I plan to integrate real-time IoT sensors for live monitoring, bring in multi-temporal data for even more dynamic risk assessments, and roll out this approach to other vulnerable regions of Cameroon. Thank you.